Okay, now we're going to start working through some of the hypothesis test questions that you are asked in the homework. I'm going to start with homework problem 10. We're going to do an example there, which is where we have a summary of the data and we're going to be looking at a mean. So before we get to the problem, let's talk about the steps for hypothesis testing for a mean with the population standard deviation sigma is known or unknown. So we start by writing the claim mathematically, which we've discussed in a previous video. We use the null hypothesis to assume the population mean and the alternative hypothesis to determine if left, right, or two-tailed test. We're going to identify the sample mean x bar, the sample size n, the standard deviation s, or the population standard deviation sigma, depending on what's given, and the significance level of alpha. Is a population or sample standard deviation given? If the population standard deviation is given, use a z-test. If only a sample standard deviation is given, use a t-test. That's the decision we'll be making. Find the critical value or values based on the significance level alpha. Use the Statcrunch normal calculator for critical values z or the Statcrunch t critical values for t. And locate the rejection regions on the graph. Now, you don't really have to do that for this class because every question, we're going to have a p-value, and we're going to be able to use the p-value to make the decision. But the homework problems and the test questions will want you to be able to calculate the test statistic. But for what we're going to do for this class, you'll be able to determine the p-value on every question and use that to make your decision, which is number 9, to decide to reject or fail to reject the null hypothesis. And then the last step is to interpret the decision in the context of the original claim. So we're going to apply these steps to use Statcrunch to work homework problem 10. For problem 10, we're given a summary of the data. A random sample of 75 8th grade student scores on a national mathematics assessment test has a mean score of 282. This test result prompts a state school administrator to declare that the mean score for the state's 8th graders on this exam is more than 280. Assume the population standard deviation is 35. At alpha equals 0.12, is there enough evidence to support the administrator's claim? And we're going to complete parts A through C. So let's just identify everything. I've kind of color-coded it for you. First, the test results prompt a state school administrator to declare that the mean score for the state's 8th graders on this exam is more than 280. So I write that as mu greater than 280. Well, I see that the condition of equality is not there. So that means this is going to be in the alternative hypothesis, which makes it a right-tailed test. So if you'll notice, I've moved it down here to the alternative mu greater than 280. This was the school administrator's claim. Well, the complement of that, the null hypothesis is mu less than or equal to 280. And there's the condition of equality that must be present in the null always. N equals 75, we see the green. X bar, the sample mean, is 282, which is given here. And the population standard deviation, which is sigma, is given here. So is the population standard deviation given? Yes. So we're going to use the Statcrunch z-stats, and we're going to use the summary with a summary because we have a summary of the data. So we're actually going to run the test, and I'm getting ready to do that for you here. But if you'll notice, what did I punch in? 282 for the sample mean, standard deviation 35, sample size of 75, the hypothesis test for mu equals 280. The alternative hypothesis is right-tailed or greater than 280. And notice I have a test statistic right here, a z-stat of 0.49 rounded to 2 places and a p-value of 0.3103. Well, let's look at 0.3103. When compared to given alpha at 0.12, we see that, yeah, 31% is quite a bit larger than 12%. And remember our rhyme, if the null is high, it must fly. So we're going to fail to reject this one. So let's see what this actually looks like in Statcrunch. Oh, it's not going to cooperate. So 282, 35, hang on a second. I should have wrote this down ahead of time. 282 and 35, 75, 280. Okay. Now, let's go ahead to Statcrunch. I'm going to go stat, Z-stats, one sample with a summary. Everybody look at that. And now I know that sample mean is 282. I know the standard deviation is 35. I know the sample size is 75. The hypothesis test for is equal to 280. Remember, in Statcrunch, we're only going to see a equal to rather than less than or equal to, greater than or equal to. And my bottom choice is greater than 280. I'm ready to click compute. And there you see the Z-stat 0.49, p-value 0.3103. It's enough to complete this question. So I'm going to move away from Statcrunch now. Let's go ahead and close this. And let's go down and look at how we've actually worked through the problem then. So all the information is repeated again up here. So yes, we show a null hypothesis of mu is less than or equal to 280, an alternative hypothesis of mu greater than 280. We did find our standardized test statistic Z, even though we don't need it to make this decision, we still need to find it, 0.49. We rounded to 2 decimal places. We haven't been doing a good job of paying attention to the rounding here on some of the exams, by the way, so be careful with that. Find the p-value, round to 3 decimal places as needed. Well, here's interesting. I've rounded it to 4 and it took my answer. So it looks like 0.310 would have been enough, but it took the answer anyway. So, but that's what I'm talking about I wasn't careful right here of how far I rounded it, but apparently they had built a tolerance in there and I got away with it. Fail to reject. We said that would be our decision. So how do we interpret that decision? At the 12% significance level, there is not enough evidence to support the administrator's claim. Since we failed to reject the null hypothesis, we do not have enough evidence to support the administrator's claim, because if you remember that the administrator's claim was in the alternative hypothesis. So we would have needed to reject the null hypothesis to be able to support the administrator's claim. So again, the decision is at the 12% significance level, there is not enough evidence to support the administrator's claim that the mean score for the state's 8th graders on the exam is more than 280. The next examples, we're going to do one with the data, but this is how to do one with the summary when our population standard deviation is known. I hope you find this helpful.